Hi, my name is LISHAALLANI MURUGAN, number matrix AA1900531. I'm from group 22. So for this FYP project, my group members and I have chose the topic Smart Plant System. For the introduction part, as we all know, nowadays people are becoming more worried about their health and also the food they consume, as a lot of food nowadays are becoming chemicals and also things that will harm our health. Thus, the amount of people doing urban gardening increasing all over the world. Especially in Malaysia, the amount of people doing urban gardening is increasing year by year as per statistics. So this is the statistical graph that shows the share of urban population in total population is increasing from year 2009 until 2019 in Malaysia. However, people are being so busy in their everyday life for their duties and also responsibilities. So they do not have much time to take care of their plants at home. Thus, an idea to create a system called Smart Plant System is found. This system consists of some specific sensors such as light intensity sensor, temperature sensor, humidity sensor, soil moisture sensor, and so on. This system will also consist of Arduino, Node MCU, water valves, jumper wires, and so on. So, this system is basically created to monitor and also water the plants. However, in our project, we are focusing on monitoring and watering a tomato plant, as tomato plant is considered as one of the most planted plant in Malaysia, and we are only considering two parameters, which are the temperature surrounding the plant and also the soil moisture level of the plant. So, as per researchers, we found that the suitable temperature for a tomato plant is in between 23 until 33 degrees Celsius, while the soil moisture level required for a healthy tomato plant is 70% until 80%. So, the sensors, which are the temperature sensor and also the soil moisture sensor, will sense the parameters and send the signals to Blink application in smartphone. The owners can press the button in Blink application to make the water valve open and water the plants. So the further chronology of this project will be explained in flowchart part and also the scope of projects. Next is the problem statement why we are creating this smart plant system. So as I mentioned before, people are being too busy to take care of their plants at home until they tend to forget to water their plants and also to monitor their plants as well. Thus, this system will always remind and alert the owners about their condition of the plant via the Blink application. So, in the Blink application, the owners can always refer to the gauge, which will represent the soil moisture level and also the temperature level surrounding the plant. This system will also help the owners to water their plants by just pressing the virtual push button in Blink application, which will make the water valves open and water the plants. Next is the objective of our project. So we are having three objectives for our project, which is the first one is to develop an Internet of Things based monitoring and watering system for plants. And the second one is to monitor the temperature of the surrounding of the plant and also the soil moisture level where the plant is planted. And the third objective is to control the watering of the plant in manual mode via smartphone application, which is Blink application that we are implemented in this system as well. The next part is project scope. So this project started when we started doing researches on Internet of Things and also the basics of smart plant system. After that, we did a simulation in Proteus and also Arduino using virtual outputs such as LED and so on. After that, we customized Blink application to tally to our project, which is setting the gauge to represent the temperature surrounding the plant and also the soil moisture level, and also the notification settings to pop up the notification when the soil moisture level is below the desired soil moisture level, which is 70% for a tomato plant. After that, we develop and prototype on tomato plant which we refer to the simulation that we done in Proteus and also Arduino. After that, the sensors in the prototype will sense the parameters required, which is in this project, we are focusing on temperature and also soil moisture level. The Node MCU will receive the data from the sensors and transmit the data to the Blink application. Then, a notification will pop up in the smartphone when the soil moisture level is below 70%. This notification is to remind the owners to water their plants. After that, a virtual button in Blink will be pressed to open the solenoid water valve in real output to make the water flow from the water tank to the plant. Then the project is complete.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Siti ASIAH binti ISMAIL, battery number AA191719. Next, I will be presenting about methodology. So, in this part, I will be presenting about introduction to methodology, the overall system, the operational flow of the system, and lastly is the electrical design. So, introduction to methodology. This part will discuss about the method used to build the smart plant system. There are few processes involved in the implementing of the system. The first one is to gathering information needed to build the overall system. Second is to design. Third is coding. And lastly is testing. There are 4 phases of the development of the smart plant system. In phase 1, we have done research about the system that is going to be implemented. In phase 2, we have been designing the circuit of the system in Proteus software for simulation. In phase 3, we have implemented coding as required for the system functionality. And lastly, in phase 4, we have built the system prototype and see the success of the system to see how the system would function in real life. Now, let's take a look at the overall system. The implementation of this smart plant system mainly focuses on the main units such as power supply, sensing unit, control unit, and output unit. This system uses 2 sensors, which are the temperature sensor and the soil moisture sensor, that continuously send data to the Node MCU, which are then transmitted wirelessly to the Blink application before turning on the water pump based on the range values that has been set up. The Node MCU operated in range of 3.3 volt, while the solenoid valve operated in the range of 12 volt. To get into more details about how the system operates, let's take a look at this operational flow of the system. Essentially, as the power supply always on, the system will monitor the temperature value of the surrounding air and the soil moisture level, and then display the sensing value in the Blink application. For soil moisture sensor only, if the reading displayed in the application is less than 70%, a notification will be sent to the users to water the plant. When users respond to the notification by pressing the push button, the solenoid valve will open and start watering the plant until the moisture level reaches the ideal level. But if the reading of the soil moisture display is more than 70%, there are no further action need to be taken by the user, and the reading will only be displayed in the Blink application. And for the last part in methodology, let's take a look at the electrical design of the system. Suppose in this electrical design, the microcontroller used is Node MCU, but for the simulation, Arduino Uno is used instead of Node MCU because there is no library for simulation component of Node MCU in Proteus software. As for the solenoid valve, LED is used to replace the functionality of the solenoid valve in the simulation. Therefore, the component used to build the electrical circuit of smart plant system is soil moisture sensor, DC generator, temperature sensor, Arduino Uno, serial monitor, LED, 12-volt relay, and 12-volt DC power supply.
Assalamualaikum warahmatullahi wabarakatuh. My name is NURULFARAH. I'm BINTI NORHAN. My matrix number is AA191215. For this project, we have 2 systems we implemented, which is monitoring system and also watering system. Now, result of this project, in the site of monitoring, we have conducted an observation which we carried on 3 different specific time, 9 a.m., 2 p.m. and 9 p.m. Now, moving to this reading, we can conclude that each parameters are depending on each other. So, as the temperature of surrounding increase, we can see here the soil moisture and humidity of air also decreases. As to why soil moisture decreases, it is because as the temperature of surrounding increase, more water from the soil will be evaporated to the surrounding. And also, as the humidity of air decreases due to the high temperature of surrounding, it will cause the soil to easily dry out. Okay, so this is the reading for the parameters from our monitoring system. Moving on, for the result of this project, we can focus on the watering system. Now, we have carried out the 3 days observation. This is the time where the push button on the blink application is pressed. So, after the notification on blink application has popped out to notify users to water their plant, we can see here the soil moisture falls below the range 70% or 716.8. So each time the soil moisture level is below 70%, the users will be alerted by blink application. Okay, so this is the time where the users will press the push button to water their plant. Now, this is the time taken on how long the plant to regain its suitable soil moisture level, which is above 70%. So each day, day 1, day 2, day 3, this is the time taken where the plant will be supplied with water until it slowly recovers its suitable soil moisture level. Okay. Now, this is the average time taken among these 3 days observation. So we can conclude the average time taken for each plant to regain its suitable soil moisture is around 17.5 minutes. So from here, users can set a timer 17.5 minutes each time after they press the push button to avoid overwatering. We can also see that the range of time where the push button is pressed is around 2 p.m. and 4 p.m. From here, users can also stay alert to water their plant.
Next, we will move to the another part, which is the simulation of smart plant system using the Proteus 8 software. But before that, let's take a look at the simulation first. Okay, that's all for the simulation. From the simulation, we can see as the simulation start running, the serial monitor will display the temperature value and soil moisture level value that is collected from both of the sensors on the virtual terminal. And in the simulation that I have played just now, the moment the LED is turned on, it means the moisture level is below than the referred moisture level, which is less than 70%, and that causes the relay to energize. When the relay is fully energized, the solenoid valve will open and allow water to flow to water the plant. And for 12-volt power supply here, its connection is connected to the whole circuit. And from the overall thing about this simulation is that from the simulation, we can say that the coding and the circuit that we have been designed is successful and it can be applied to the prototype. That's all for circuit simulation. Thank you.
This is the coding that we use for our project. So this is the library that we have already installed for the system. And then the Wi-Fi and password for connecting the Node MCU and our Blink. And this is the command for our system. Okay. Then we can see here that there's a serial print. Okay, so the outcome from this, after we compile, there is no error, and then we can already upload the coding into NodeMCU. That is for coding.
A 12-volt solenoid valve, power supply 12-volt, temperature sensor, soil moisture sensor, and a NodeMCU. From here, push button on the blink application has already been pressed. We can see that water start flowing from the water valve to the plant. This because relay will energize and 12-volt power supply will be connected to the solenoid water valve, allowing the valve inside to lift. Then, the push button is pressed off, closing the valve from supplying water to the plant. This is a close-up on how the water is delivered to the plant.
Next, let's move to the conclusions part. So the conclusion for our overall project is this system was able to sense the parameters successfully, and the signals was then successfully transferred to blink application and able to give notification to water the plants when the soil moisture level is below 70%, and this system will also able to water the plant when the owner press the push button in blink application. And in the nutshell, this system will definitely help people all over the world to take care for their plants and also vegetables at home, as it will ease their job to water and also monitor their plants by just referring to the blink application. Other than that, this system is also suitable for real life application, but some improvements can be done to make this system more beneficial and for make this system high demand. So what are the improvements that can be done is the first thing is some other important parameters can be also considered in this system, such as the light intensity for the plant and the pH level required for the specific plant and so on. Other than that, automatic fertilization system can also be added to this project, which is it will fertilize the plant whenever the plant is in need, or the fertilization process can be done in the suitable time duration gap. And the last recommendation is an automatic watering system can also be implemented in smart plant system, which the owners no need to press the push button in blink application to water the plants, but the water valve will open automatically when the sensor sense the soil moisture level is low or whenever the plant needs water. So the implementation of automatic watering system is one of the highly recommended improvement that can improve in the future projects of smart plant system. So that's all from me. Thank you.